When we use modern RPA tools to automate processes, we don't really need to know any programming. There are certain activities we'll use for our automation that will use some snippets of VB.NET script. So it does help to have some experience doing some basic programming so you can see that VB.NET code in its natural environment and understand it better in order to apply it to the activities you're using in the RPA tool. So in this section, we'll have an overview about programming basics. We'll create a simple program just to underscore how different programming is than using an RPA tool. I'll cover variables and data types because those are integral in either programming or RPA. We'll take a quick look at the difference between using an app versus an RPA tool to do the same thing, and we'll examine the pros and cons of doing either, and maybe even talk about how you could use a combination of applications and RPA tools to accomplish a task. We'll talk about functions, which simply means to break a process down into smaller parts. Then we'll talk about object-oriented programming concepts like classes, properties, and methods. And finally, I'd like to introduce you to the .NET Framework documentation because all of these things I've been talking about are documented there, and it's great to understand how to navigate the documentation so you can more effectively find objects and methods to use when you're using a modern RPA tool to get some work done. At a very, very high level, I'm hoping this section will help you understand the difference between programming a Windows app and the results you might get from that versus using an RPA tool and the results you might get from that. Generally speaking, when we create a Windows app, we're primarily using only what we call the .NET Framework to do things. And that's basically a layer of stuff that somebody else already programmed that allows you to use as building blocks to get things done. When you write your program, it gets compiled into a single file called an executable. And you've seen that before. It's basically a file name that ends in the extension .exe. Compiling means that the script that you wrote is translated into instructions that the computer can read faster. For that reason, compiled apps can run very, very fast because the computer is not having to translate every line of code into something it understands. RPA tools, on the other hand, are a layer on top of several different technologies. One of those technologies is the .NET Framework, like we used above in the Windows app. RPA tools, though, are designed to drive other technologies as well, like Selenium WebDriver can be used to control web browsers. There's image recognition technology that helps us do surface automation. And there's also OCR, which is optical character recognition, that allows the RPA tool to read text that actually is in an image format on the screen. An RPA tool provides a common look and feel when we're interacting with different kinds of targets. So when you're using the .NET Framework stuff, you don't have to write .NET Framework code. When you're using the Selenium WebDriver stuff, you don't have to write Selenium WebDriver code. You basically drag and drop activities on that all look and feel the same, and under the covers, the RPA tool is using whichever technology it needs to accomplish the task. The resulting scripts are what we call declarative, and that just means it's a bunch of text lines in a text file. It's not compiled. Of course, there's an engine that is created by the RPA tool vendor that is capable of reading that file and translating each line into something that the computer can execute. Because of the fact that the RPA tool engine has to read that file and translate those lines, it's going to run more slowly than a compiled Windows application. I know this stuff is kind of academic and theoretical, and it might be hard to envision right now, so that's why I want to use this section to put your hands on the tools and make some of these ideas more concrete in your mind. So let's jump into it. The first thing I want to do is show you how to build a simple program, because we can use this simple program as a foundation to experiment with some of the .NET Framework capabilities. So I've opened up Visual Studio, and I'm clicking on File, New, Project. And inside this New Project window, we can expand this Installed node here, and notice we have Visual C# projects or Visual Basic projects. Visual C# is a very popular programming language, and we can use it to create applications that our RPA tools can use as helpers. Since UiPath uses a lot of Visual Basic snippets, I'm going to stick to Visual Basic for now and show most of my examples using that language. So I've expanded Visual Basic, and I'm clicking on Windows Desktop. And notice there's a bunch of stuff we can choose from here, but we're going to use this thing called Console App. And that's just going to allow us to create an application that looks like this Windows command prompt. Notice it's blinking there and waiting for me to type something. And if I type in dir and hit return, it takes some action and then waits for me on the next line. So this is a console application. It's not real fancy, but it's a lightweight way to get started, and it's quick for us to be able to experiment. So I've clicked on console app. I'll call it simple-app. You can name yours whatever you want. I'm saving mine in C Development VS, which is short for Visual Studio, but you can leave yours in the default directory if you want. Notice we have an opportunity to select which version of the .NET framework we want to use. Currently, the highest available in mine is .NET Framework 4.6.1, but that's only because that's the version that shipped with this Visual Studio installer. I could go out to Google and type in .NET Framework download, and I suspect there's a newer version of .NET Framework out there, so I could install that and use that, and it would show up in this menu if I want to. There haven't been any recent dramatic changes with .NET Framework, so I'm not going to worry about that. But your company might be limited to which version of .NET it uses. So you might only see .NET Framework 4 or 4.5 or whatever. So I'll just leave it at .NET 4.6.1. You can use whatever's visible on your computer. I will leave this checked to create a directory for the solution and click OK. This results in a new blank project being created. And if we explore this window on the right side, we see that the project is called simple-app, and there's a module inside the project automatically named module1.vb. So that reflects the fact that this is one VB file that contains some script. We can rename that file to whatever we want. So for instance, if I click on here and just rename this main module and hit return, it says, hey, you're renaming a file. Would you also like to perform a rename in this project of all references and code, yada yada. So if I click on yes, notice the name of the file has changed, and also the name of the module inside the file has changed as well. When I click to expand this, since we're looking at the Solution Explorer, it's showing me the name of this module inside the file. And if I expand this, it's showing me the name of this executable section here called a subroutine inside the file. So this thing is actually ready to run. If I click on the Start button up here, the application will be built and it will run. So I'll click Start. Notice it's building down here, and when it's done building, it runs and goes away. So that wasn't very exciting. What we can do to keep the application open is to take advantage of a .NET Framework object called console. So when I type in console, notice all this IntelliSense starts popping up because Visual Studio is aware of what console is. And console represents that window that we saw pop up and go away. So if I say console dot, and by typing in dot, that's telling Visual Studio that I want to access something that console contains or can do. And you see these little cubes, those all represent something that console can do. If I scroll through this list, you see some of the cubes read like verbs. Read, read key, read line, reset color, and so on. I want to have it read a line because that's going to make the window pause and wait for me to type something. So I'll double click on read line, and notice when I click away, Visual Studio adds these parentheses to the end of that line. If you've never done any object-oriented programming, seeing these dots and parentheses might be a little bit confusing. So one of my goals for this entire section is hopefully that you'll become more comfortable with when and where we use dots versus parentheses. Oftentimes you'll find that the tools help us put them in place when we forget to, but it's still important to understand why they're there and how to use them to your advantage. So this time when I click Start, the window opens up and it waits for me to type something. If I type something in and hit return, that's when the window goes away. Much in the same way that I used console.readline, I can place my cursor after main there and hit return and type in console tab.wri, and notice it's showing me my options to write or write line. So I'll double click on write line and notice what happens when I open up my parentheses. This little window pops up with up and down arrows that says 1 of 19. And what that means is there are 19 different ways we can use console.writeline. And the way that they'll be differentiated is what is in between these parentheses. So in this case, it's saying, hey, one option is console.writeline with nothing in the parentheses. And that says it will write the current line terminator to the standard output stream. And that just means it's going to add a blank line on the screen. If I use the down arrow here, now notice something showed up between these parentheses. Now it's saying we can do a write line with a value of type Boolean. And I'm going to talk about variables and data types in the next lecture, but for now, just know that a Boolean is a true or false value. If I click the down arrow again, I can write out a single character. Click it again, character array. And you don't know what that means yet, but that doesn't matter. Click on the down arrow again. I can write a value as a decimal, or a value as a double, or a value as an integer, which is just a number. And finally, value as a string. And that's the one that I want, because a string is a series of text characters like a sentence or a phrase. So I have just found out that I can use console.writeLine with one single string value, and that's an acceptable thing to do. So I'll open up some quotes and type in hello to the console. And like I discussed, I can copy, paste that back in, and actually leave this as nothing. And that's going to write a blank line. And I'll copy and put another one of those in and say, this is my second line. So now if I put an apostrophe in front of this line, that's going to comment it out, so that extra line won't be written. So when I run now, you see that my first and second line are right next to each other. If I hit return, it goes away. If I remove that apostrophe, now that line is going to be compiled and executed. So if I click start now, you can see there's an empty line now between my two lines. So I wanted to remind you that these lines of VB.NET code that I've written are being compiled into a single file in a language that the computer understands very well, so it runs really quickly. If I right-click on my simple app and scroll down to the bottom here and select Properties, the assembly name is the name that's going to be used for this file that we compile. Again, we can change the .NET framework that we're using, and we can even choose which application type we're dealing with. What's important is over here in the Compile tab, you can see the output path where this file is going to end up. So in the case of a debug version of the application, it's going to go into our current project folder and then inside a bin directory and inside a debug directory. If I instead choose to build the release version, it's going to go in bin release. And like I mentioned before, it's going to have this name, simple-app. So we can actually go see that if we right-click on here and use the Open Folder in File Explorer item. That takes us into our C Development VS Simple App directory inside the Simple App project folder. And when I double-click on bin, remember that's where they were in this Compile tab, we see the debug and release versions. I ran the debug version, so we will see our application file in there. I never did run the release version, so that's not there. If I come back here and select the release version, I can either just build it, or if I choose to run it, it will automatically build and then run. So if I use build here, notice it shows that it's building down here at the bottom, and it even tells us which path it's going to be in, and that's bin release simple app. So if we jump back in there, inside of our bin release directory, now we see that version of simple app. So the fact that I have these binary folders and files means that I don't need to use Visual Studio anymore. I can jump right in here to the release version and just double click to run this app. And just like before, it shows me those two lines and it waits for me to type something. When I type and hit return, it goes away. So we have created a console application that you could copy and paste anywhere on your computer, and it will do whatever you programmed it to do. So hopefully that demystifies computer programming a little bit and helps you understand how the process is done and how it's different from using an RPA tool. To really drive the point home, let's compare and contrast how to do the same thing with an RPA tool. In this case, we'll use UiPath. So I'm going to click on blank to create a new blank project. I'll call it simple-app, copy and paste that down here into the description and click on create. And now with a blank UiPath project file, we don't really see anything over here in the properties or in this canvas, but over in the project, we do see our main.xaml file. And I can run this just like I did the console application with nothing in it. So if I click on play here, at the top left, UiPath disappears and comes back, and nothing really happened. Down here in the output, we can see that it ran, and if we click here to show the timestamps, you can see it took basically no time at all to start and end. So to simulate what we did before in the console app, I can click on Activities, type in SEQ to find a sequence, drag that sequence container onto the canvas, and then go back into Activities and type in logm to look up log message. This is very similar to console.writeLine. So I'll drag one of those in here and click in the message area, open my quotes, and say, hello from RPA. And then I can click on that, Control C to copy, and then click below it, and Control V to paste. And now I can say, this is my second line, similar to what we did before. If I wanted to wait for user input, that's not really something we do in RPA robots very often, but it's possible. I can type in input up here, and notice we get this input dialog. So I can click and drag that under here, and I can open my quotes to put a title on, just say type something, and then down here, type some text. So now when I run this, it simply pops up this dialog that says type something and type some text. So now of course I can type in whatever I want and hit return. And down here in the output, you can see we get hello from RPA. This is my second line, and that ran between 16:58:44 and 16:58:51. So there is a compiled application sitting in the background that UiPath uses to execute these steps. But these steps do not get compiled into a single application. They live in this project file right here, and if I use Control A to copy that path and paste it into my Start menu, we can see that file is right here, and if I right-click and select Edit, we can see it's just this long blob of text. So when that UiPath robot application does run, it needs to read all of these lines and translate them into something the computer can understand. So hopefully that helps you see the difference between writing and running a program versus using an RPA tool to accomplish a similar task.
Let's spend a little time talking about functions, and this also includes the topic of subroutines. Essentially, using functions or subroutines allows us to break up a long process into smaller parts that are more easy to think about and program and manage. The idea is to create multiple, small, reusable pieces of logic that go together to form a larger process. When you're thinking about creating reusable pieces of logic, you're going to want to consider whether that piece of logic will be only reused within a single process or it will be reused within multiple processes. If you're only going to use it within one process, you can usually keep it in the same folder as the process that's using it. Oftentimes, if it's going to be reused within multiple processes, you may have to consider creating a shared folder that multiple applications or multiple software robots could all access. And that makes the process of maintenance easier as well, because if you have to fix a problem or enhance that shared piece of logic, you can do it one time in one place, and all of the applications or robots can benefit from that one change. When we talk about functions in terms of programming, there are 2 or 3 different kinds, and we'll talk about 2 in these lectures and a third one later when we talk about classes. A subroutine is a small, reusable piece of logic that does some work but doesn't return any kind of a value as a result. Whereas a function does pretty much the same thing, but it returns a value that resulted from the work it did back to the application that called it. RPA tools, on the other hand, work slightly differently. As you'll see in my UiPath Level 1 course, we have the ability to break up longer processes into things like sequences or flowcharts. And those activities are containers that are generally only used once within the robot. And if you do need to use them again, you would have to copy the whole thing and paste it later on in the robot. And that creates duplicated steps, as opposed to reusing one thing. The other slight downside or consideration is that you can't pass information into them. They're pretty much self-contained, they have a series of activities they do, and then they move on to the next sequence or flowchart. The other thing we can do with an RPA tool like UiPath is to extract workflows. This is where you select a series of activities and you specify that you want to extract a workflow as a separate file that contains those activities.
And since it is in a separate file, it can now be reused again and again within one or more software robots. Another benefit is you can use the arguments feature to be able to pass data into and get data back out of the workflow. The bottom line with functions or subroutines or extracted workflows is that you employ what's called the DRY principle, and that stands for don't repeat yourself. Like I mentioned above, you wouldn't want to copy and paste a sequence that has several activities over and over and over again, because then if that sequence needs to be updated, you would have to go and change every instance of that sequence within your program. That's what it means to repeat yourself. You're going to want to be thinking in terms of abstractions, where you close your eyes and you visualize a mental model of what the process does. And if you see certain things that repeat over and over again, that'll be a good clue to you that you could extract that part as a workflow and reuse that either within one robot or across multiple robots. A great example of something like this is logging into a popular website within your organization. If you've got a CRM like Salesforce, for instance, multiple robots may need to log into Salesforce to do some work. So that's a perfect case to extract the steps for logging into Salesforce into a workflow that can be reused within one or more robots. In the next two videos, let's have a look at how we can use functions within traditional programming and an RPA tool. Okay, let's have a quick demo and see what it looks like to use functions and subroutines within Microsoft Visual Studio. I've got Visual Studio open. I'm going to create a new project using New Project. We'll create a console application like we did before. So I'm in Visual Basic, Windows Desktop, and I'll select Console App. I'll name it Functions-Demo, and I'll save it in C Development VS. You can put yours wherever you want. I'll leave everything else pretty much default here and click OK. So now, like usual, we've got our main module, which is a VB file. We could rename that if we want to. And we've got our main routine here, which represents the program. If I run it right now, it will open and close. So let's go and add our console tab dot read and double click on read line. That'll keep the application open when we run it. And to give you a basic idea of how subroutines and functions work, I'll just use my console tab dot write line again. And inside those parentheses, I'll just type in line 1 and close up my quotes. Triple click on this line, Control C, Control V, and Control V again. And now we'll have line 2 here. So we've got a program that's going to write line 1, line 2, and then stay open. So I've got it set to debug, and I'll click on Start. And exactly as we would have expected, we see line 1, line 2, and now it's holding for us to type some information in. We can just click on Close to dismiss that. So again, the reason why we create subroutines and functions is to break up a complex process into smaller parts. So to demonstrate this, I will simply take line 2 here and put that into a subroutine. The easiest way to create a subroutine is just to click after the end sub of main here, hit return a couple of times, and just type in the word sub, which is short for subroutine. Then hit a space and give this subroutine a name. And since this is just a demo, I'll type in my sub demo for the name and hit return. Notice it automatically placed some parentheses after the name of the sub, and it automatically added end sub. So you can see that this looks a lot like sub main up here. Now if I simply select over line 2 there and Control X, and then click over here and paste that in, we've taken part of our logic and placed it into this subroutine. If I hit Start right now, notice that our application only shows line 1 right now. That's because this subroutine is not being invoked or executed. So the way we do that is to simply grab the name, including these parentheses, Control C, and then Control V to place that right there. So this is how we invoke this subroutine from within our program. So now the program will execute line 1 here, then it will execute this line, which takes the execution down here, executes that line, and then returns back up here to read line. So when I click on Start, now again we see line 1 and line 2. A function is slightly different than a subroutine because it's going to return something back to the calling program. So if I simply change this to function, notice Visual Studio automatically updated this end statement here to end function. And it's showing me a green squiggly line that says my subdemo doesn't return a value on all code paths. So what that means is I just need to click over here and hit return and type in the word return. That's what's going to allow us to return something back to the calling program. So I'm going to return a string or a series of characters back to the program by opening my double quotes and just typing in "you called the subroutine." So my program will print line 1, it will call my subdemo, which will then print line 2, and then return this information back up here. So we need to receive the information that's being returned. And I could either assign that to a variable to store it for later use, or I could simply just wrap that up with a console.writeLine. Because console.writeLine can output the information that's being returned from this function down here. In order to do that, all I needed to do is Control X that and place it right inside these parentheses like this. So now, in a sense, this is kind of a placeholder for this string that's going to be returned down here. So if I start the app, it's exactly what we expected. Line 1, line 2, you called the subroutine. So that's the most simple way that I can show you how to use functions and subroutines. Let's delete all this and I'll show you a more common way to do this. So I'll select that subroutine and I'll delete all of these lines here as well. So a normal program, if we were doing some automation, might be something like read the customer file. And notice I'm using a single apostrophe to comment out that line. That line won't execute. It's just there to provide readability. Single quote, and I'll type log into system A. And here I'm just making comments about the various steps that our application is going to perform. Maybe this one is enter customer data into system A, and then here we would have log out. So this is what I would call pseudocode, that is simply writing comments to indicate the general flow that's going to occur inside the application. I'm not going to write any real steps here. We'll just use console tab dot writeLine again to create some fake steps. Add my parentheses and my double quotes, and we'll just say read file dash step 1 and close the quotes. Now if I triple click on this line, Control C and then Control V 2 more times, I can paste in a couple more steps to simulate what we might be doing in this read customers file. So now I'll select over those and paste them here, hit return, and I'll just change this to login. Select that and paste it over these. Select that whole thing and paste it here. And I'll just change that to enter data. Control C to copy, Control V to paste in these 2 spots. And maybe log out is only going to have 2 steps. So I'll copy that and paste it here and hit return. Change this to log out. Double click to Control C, Control V. So now we've got a simulated program that's going to do some steps to read the customer's file, do some steps to log into system A, do some steps to enter customer data into system A, and then finally log out. What we would most likely do would be to add some kind of a loop. And for each of these customers that we read, we would enter that data into system A. But I'm not going to get into that right now. I just want to show you how to essentially extract these steps into subroutines or functions. So Visual Studio has this cool feature where you can select all of these lines and then right-click and select this Quick Actions and Refactorings. So if I click on that, it's giving me an opportunity to extract a method. And you'll see in the UiPath lecture that this is kind of similar to selecting several activities and extracting a workflow. If I click on this, it presents another dialog that allows me to rename the method that's being generated from this action. So I'll double click on that and I'll just type in read the file with no spaces. So you can see that it's been renamed over here as well, and I've got a few options I can select. When I click apply, you see that those 3 steps have been replaced by a subroutine call that says read the file, just like in our last demo. If I scroll down, we'll find that Visual Studio automatically created a sub for me called read the file and placed those 3 lines in it. So that's a fast way to extract subroutines out of a series of steps. And hopefully this gives you a better visual about how functions and subroutines can take a long process with many steps and turn it into something that has fewer steps that provide an easier to understand abstraction of the process. So I'll do this one more time so you get a sense of it. Select all the rows, right-click, select Quick Actions, click on Extract Method, double-click here to rename this to Login to System A, click Apply. So now instead of 6 steps, we have 2 steps. And that new subroutine has been created down here as well. If I click on Start to run this, you'll see all the steps we'd expect. 3 read files, 3 logins, 3 enter datas, and 2 logouts. So I'll let you practice converting these into subroutines yourself. Okay, in this lecture, let's compare and contrast the notion of creating smaller, reusable pieces of logic with UiPath. I'll start off by creating a blank project, also called functions-demo. Control-C, Control-V to copy that here, saving it in C Development UiPath, and click on Create. Double-click up here to close the ribbon as usual. And in my Activities panel, I'll look up Sequence and click to drag and drop one into the center of the canvas here. So this sequence is very similar to our main subroutine that we saw in Visual Studio. It's a little more cumbersome to build up multiple steps in UiPath because we're not just typing some lines of code like we did in Visual Studio. I'll rename this to the whole process to give us a sense of context, and then go back into Activities and look up something like log message, because that's similar to the console.writeLine for simulating steps of a process. So here I'll do that same thing. I'll say this is read file step 1. And then I'll click on that and Control-C, and then click below and Control-V, and click below that and Control-V. Change that to 2. Change that to 3. So now I have 3 steps for reading my file, and I can actually hold my Control button down and then select those 3 things and Control-C, and then jump down here and click below and Control-V again. So now I've added 3 more steps, and I can change that to login. Double click on that, select and paste there as well. Control click on all of these, and then click under here and Control-V again. And then we'll change this to write customer data, and then select and paste that over each of these as well. So you get the idea. I'm building up a long series of steps to reinforce the fact that we should think in terms of breaking up a long process into multiple smaller processes. So you may recall with Visual Studio, we were able to select multiple steps and then right-click and have Visual Studio automatically create a subroutine. If I right-click on these selected activities, nothing happens. I'm not able to do that same kind of thing with UiPath. The first type of functions or subroutines you'd want to think about doing with UiPath would be to group related steps into a sequence or a flowchart. If I was to group these 3 read file activities into a sequence, you'd still be able to see them here inside my whole process sequence. However, if I was to group them into a flowchart, the only thing we'd see in here would be the flowchart. So the flowchart would hide those 3 steps to some degree and make our process look a little cleaner. To demonstrate that, I'll go into Activities and type in SEQ for sequence, and I will click and drag a sequence above and call this read file. So this is kind of like creating a subroutine because I'm creating a named container to hold those related steps. So now if I click on this and control click on the others, I can drag them into this sequence, and now I have this read file container that's holding those 3 steps. You can still see them, so it doesn't necessarily make our process flow easier to read. If I Control-Z 3 times to get rid of that sequence, this time I'll do the same thing with the flowchart. So I type in FLOW and scroll down to System Activities Statements Flowchart and click and drag that above those 3 steps. Now I can double click and name this one to Read File. And now when I control click on these 3 items, I will control X to get rid of them, and then double click on Read File and paste them inside. Now, of course, I'll have to hover over Start and connect them all together like this. But now when I jump back to my whole process, you can see that I've simplified things a little bit, because now instead of 3 steps here, I only have 1. And of course, I could do the same thing to encapsulate these 3 login steps into one flowchart. And the same with these 3 customer data steps. I could put those into one flowchart as well. And that would simplify what my process looks like to the viewer. That doesn't really give us any functional benefits, except for the fact that now I can right-click on this one activity, and now I can use my Extract as Workflow menu item here. So like I mentioned before, if you wanted to reuse this thing several times throughout the workflow, it would not really be a good idea to Control-C and then, for instance, Control-V it near the end here. It does allow you to reuse the same set of steps, because inside here you're going to see those 3 steps. And if I jump back to the whole process and go down here, inside this one you'll see the same 3 steps. But these are a copy of that first set of steps. And if for any reason this process changes, you'll need to change all 3 steps here, and you'll need to change them here as well. So this is violating that dry principle that I told you about before, do not repeat yourself. So this isn't a good idea to do. The better thing to do would be to right-click on this and select Extract as Workflow. And notice it's going to save it in Functions Demo. We can call this Read File and hit Create. And now you can see that Read File has been broken out into a separate file called readfile.xaml. And back over here in main, there's a different kind of activity called Invoke Workflow File. So now this truly is like a function, because these 3 steps are in a separate file. And if I Control-C to copy this and now paste it down here near the end, you can see that the first one is pointing at readfile.xaml, which contains these 3 steps. And also this one here near the bottom is also pointing at readfile.xaml. So if I was to change readfile.xaml, both of these activities would benefit from that change. I show more details about how to extract workflows in my UiPath Level 1 course, so definitely go check that out. But I'm hoping this simple demo gave you an understanding of how you can break up a process that has many, many steps in it into smaller pieces that make the process easier to read and more manageable when you need to change things. Okay, let's dig in and talk about variables and data types, because we're going to be seeing a lot of those whether we're doing programming or using an RPA tool. Simply put, variables are just a bucket with a name that can hold some information. So you see here I've got a bucket called first name, a bucket called age, and a bucket called payment amount. Each one of those buckets would hold a different kind of value. Variables allow us to construct a unit of work that can operate on different values. They also make things easier to maintain. And what that means is that you can use the data value in many different places in your script. And if for any reason that data value changes, you can change it in one place and the new value will propagate through the rest of the script. The use of variables also contributes to having fewer errors in your scripts. For instance, if we were using a first name value in 15 different places in your script, and you had to type the first name value in all of those 15 places, and then sometime later it turned out that we had to change that first name to something different, there is some chance that you could potentially misspell the first name in 1 or 2 of those places, or maybe even just forget to change it. By using a variable in all of those locations, we can simply change the value in one place and not have to worry about changing the other 15 places. Here's a visual of what that looks like. Let's say we had 3 different tasks to do in our RPA automation. This is obviously oversimplified, but let's say we have to add a customer to system A, add that same customer to system B, and also to system C. You can see I've included 3 steps of that process in each of these tasks. First, we would open a browser. Then we would type into a text box with an ID of first name, and the value would be Brian. Then we would type into another text box with an ID of last name, and type in lamb. And of course, since there are 3 different systems, we would type my name in 3 different times. Now the first thing you should notice is this only allows us to enter me as a customer. In order to enter a different customer, we would have to come back and manually change each of these values by hand. That's certainly not an ideal way to work. Variables allow us to create essentially a placeholder to hold the value. So for instance, here you see a blue rectangle that represents the value Brian, and a green rectangle that represents the value lamb. So you can see that I've used the blue rectangle for all the first name entries, and the green rectangle for all the last name entries. If I needed to change the name, I could simply do it at the top there and change the blue rectangle to Fred and the green rectangle to Jones, and I wouldn't have to worry about making a mistake in the 6 steps below. So what that really looks like, instead of green and blue rectangles, is I simply have a named variable. Like here you see customer first name and customer last name. So I've assigned the first name to Brian and the last name to Lamb, and then I've used that named variable in each of the 6 steps below. In the next video, I'll give you a demo of what it looks like to create and use variables in both Visual Studio and UiPath RPA tool. Let's first have a look at the basics of variables using Visual Studio, and then we'll go look at UiPath. I'm here in Visual Studio. I'm going to go to File, Recent Projects, and I'm going to grab this simple app that we created in the previous lectures. We've got some console write lines in here, and what these are doing is outputting what I call a literal string. These are some characters that I've typed in that it's outputting to the console. To create a variable, I can simply click before any one of these lines, hit return a couple of times, and click back up here at the top, and I can use the word dim. It's a verb that says create a space in the local computer's memory of a certain dimension for this variable. So similar to what I described in the previous video, I'll say dim customer first name. So that's the name of my bucket. And with VB.NET, I have to use the word as. So you can see when I hit the space, it's actually prompting me for this and showing me how to do it. So I'll type in as and then space. And now it popped up a window that allows me to browse through and look for different kinds of variable data types. Ideally, though, you should know these off the top of your head, so I'm not going to use that window. I'll type in string, and we'll talk about data types in a future lecture. But a string simply means a series of typed characters like this. You can see that our variable name is underlined by a green squiggly line, and when you hover over this, that just means that this variable has not been used yet. If I wanted to declare a second variable, I could simply Control-C to copy, hit return, and Control-V to paste that back in. And I could change this bucket name to last name. Now I have 2 variables, 2 buckets ready to hold some data. An alternative to that would be to delete this stuff here and back it up a little bit and use a comma between them. I can declare 2 variables this way as well, as long as they're all of the same data type. So if I wanted to create an age variable, for instance, I would say dim customer age as, and since this is actually a number, I'd like to use a data type like int 16, 32, 64, or just a plain integer. I happen to know that an int 16 will work fine for this, so I'll double click there. So I have 3 buckets now that are capable of holding data, but they don't currently have any values. So I can use something like, I'll just Control-C to copy this, customer first name equals, and then I use double quotes. Notice it closes my quotes after I type the first one. Put in Brian. I'll Control-C, hit return, and Control-V again, and back that up a little bit. And I'll select over that first right there and type in last instead, and change this value to lamb. And then I'll double click on that and Control-C to copy and paste it here, and put in my age. Notice I didn't use any double quotes around that because I'm assigning the actual value of this number to this bucket instead of a string of characters like I did with these 2. So at the beginning of the program, we have declared our variables, then we have assigned values to our variables, and then down here, we can use the values that are stored in these variables. So I'll just do console.writeLine again, Control-C to copy that, and paste it 3 times. And in this first one, I'll create a literal string by opening my double quotes and typing in first name is colon, space, and then end my double quotes, and then I'll use a plus symbol here, and then I'll simply double click to copy first name and paste it after that plus. So when the program runs, it's going to combine the value that's inside this bucket called customer first name with this literal string portion right here by using that plus sign. So I'll do that exact same thing. I'll select Control C to copy and paste that here. Double click to change this to last name, and then type last name here. And then Control C, Control V to paste there. Select over that and type age is. Of course, we want to put in customer age here. And when I double click and paste that and click away, you can see that it's not reporting any problems, even though this variable is not a string. When I hover over it, you can see that it says customer age is a short. So I'm going to switch this back to debug up here to give us opportunities to debug if we need to. And let's go ahead and run this and see what happens. It gave us an error dialog, and it's telling us we have an unhandled exception. And it says that conversion from string age is to type double is not valid. So as I expected, the program wasn't smart enough to convert this number to a string so it could add them together. So what we have to do in that case is after customer age, use this dot to indicate that we want to use some kind of method that this variable is capable of doing. And the method that I want to use is toString. So when I click away and run again, now you can see we got what we expected. First name is Brian, last name is Lamb, age is 50. So you can see ultimately what we did here is declared our variable at the top, so the program knows how much memory to allocate for each of these buckets, and we had an opportunity to name the buckets. Then we assigned values or put stuff into the buckets, and then later on in the program, we used the contents of those buckets to do something. So like I mentioned in the previous video, if I Control C and then Control V to paste those in again, and let's put a blank line between them. Sometimes your program might use the same values 2 different times. Like maybe this is putting it into system 1 and this is putting it into system 2. If I was to have typed Brian Lamb 50, Brian Lamb 50, there's a chance I could make a mistake there. And it also would only give me the ability to do that work with that dataset of Brian Lamb 50. Whereas by using these variables, it gave us an opportunity to create some logic in an abstract way that says, hey, we're going to do some work here with first name, we'll do some work with a last name, and we'll do some work with an age, but we're not locked into one piece of data for any of those commands. If I run this now, you see that I get 2 sets of Brian Lamb. And for me to change that, I can simply go up here and type in Fred Jones and change his age to 30, hit start, and now as you would expect, we get 2 sets of Fred Jones. So that's how easy it is to use variables in Visual Studio. In a previous video, we saw what it looks like to create and use variables in Visual Studio. Let's do the same thing with UiPath. So I've got UiPath open. I'm going to open up the recent simple app project we created. Double click on the menu to close up that ribbon there. And similarly to our Visual Studio project, we've simply got a sequence here which logs 2 different lines and then pops up an input dialog. I'm going to right click and disable this for now. I'm only going to cover the very basics of creating and using variables in UiPath Studio, but my UiPath Level 1 course goes into greater detail. So ultimately, this top level sequence in our main canvas area represents this main routine we have here in our Visual Studio app. It's basically one level with a series of statements that we'll execute. And notice up here at the top, we declared our variables and then we assigned values to them before we used them. You can do kind of the same thing in UiPath. And the key here is this variables tab down here at the bottom left. When you click on that, it shows you which variables are visible in the current scope that you might be looking at. And I'll talk about scope in a future video. So when I select this top level sequence, I can use this design menu to create a variable. And when I do that, it allows me to choose between a small number of data types. Text is the same thing as string. So I'll select that, and I'll select over and change this to customer first name, just like we did in the previous project. I've got an ability to set the default value for this, but I'm not going to do that right now. That would simply give this bucket some contents right when I created it. And sometimes that's a useful thing. If I click on this global variable checkbox, that will ensure that this bucket is visible to all future activities in the robot. And that technique falls under something called variable scope, which I'll cover in a future video. For now, I won't check that and click OK. So you can see down in this variables tab, we now have a variable called customer first name of type string, and the scope of it is this sequence right here. So I can do that again by clicking design, create variable text. We'll say customer last name, just like we did before. Click OK. So now we have two variables. And one more, create variable, and this time we'll do a number. We'll call this customer age, and click OK. So now, much like our Visual Studio declaration up here, I've got a first name and a last name of string, and a customer age, which is a number. Now we need to assign some values to them. I'm going to close up this variables tab, and the way you can assign values to variables in UiPath is, not surprisingly, by using an activity called assign. And instead of dragging 3 of these on, I'll just click and drag 1 at the top here, and then Control C and Control V, 2 more of those. And that's going to be very similar to this assignment section that we did right here. So UiPath is cool because it's aware of the fact that these variables exist. The way that we use these assigns is we say assign some kind of value or VB expression to our variable. So if I click in here and start typing CUS, notice that UiPath is aware of the fact that those 3 variables exist, and I can simply double click to select one of them, and then click over here and use double quotes to type in the value we want to assign to that bucket. If you need more space to do that, you can always jump over here in the value section and click on these 3 buttons, which pops open a resizable window. We're using simple values, so I won't use that for now. I'll double click and Control C to copy that and paste it in this one. And again, change this to last name and open my double quotes. Type in lamb. And here, again, CUST, tab away to select customer age and type in 50 again. So now by using 3 different assigns, I have basically achieved the same thing that I achieved here. Now we need to do something to do some work with them. So to do that, you may recall that we used log message to write stuff into this output area down here. So we'll do that same thing. I could either go over here into activities and type in log message and find it there, or simply Control C on one of these and then click after it and then Control V to paste. So I'll change this string here to first name colon space, just like we did before. And I'll click after that double quote and use the plus sign, just like we did before, and start typing CUST. And notice that it's still aware of those variables we created, so I can double click to select that one. Now I'll Control C and Control V again. Change this variable here to last name to use that different bucket. And of course, I'll change the label here to last name as well. Control C and Control V here. Change the label to age. And of course, type in customer and double click to select customer age. So notice I'm not using toString on this one. Let's go ahead and run this and see what happens. So I click play, and UiPath returns with no issue. And notice we get first name Brian, last name Lamb, age 50. And of course, if I jump up here to the top and change those values to Fred, Jones, and 30, and run again, clicking in output, we see the exact same thing, Fred, Jones, 30. So why did our VB.NET program complain when we tried to add things together? The secret lies in the fact that when we created that age variable, we created it as a number. And if we jump down here to our variables, we can see that customer age is in fact what's called a generic value. UiPath used that as a convenience for us because it allows this number to more easily be converted to a string when necessary without throwing an error. I can override that and change this data type by clicking on it and selecting something different like int 32, or even going down to the bottom, which you can't see here, and selecting this thing called browse for types. And then inside this window that pops up, I can type in int and scroll down a little ways. And at some point I find this MS Core Lib system, int 16, int 32, int 64, this matches what I used over here in my Visual Studio project. You may recall that when I typed in as here, it gave me the opportunity to use int 16, int 32, int 64, or integer. I chose int 16 because it uses the least amount of memory of all those options. If I wanted to here in UiPath, I could do the same thing, or I can simply leave it as generic the way UiPath suggested. Of course, if I do change this to any one of those ints and close up the Variables tab, notice unlike my Visual Studio project, this one is complaining and saying that the conversion between string and double is disallowed. And that's just a hint that tells me I need to use this dot. And notice the similarity here. We've got this toString, so when I double click on that, the error goes away. So hopefully that gives you a clear idea of how this UiPath RPA tool is really kind of doing the same thing under the hood that our VB.NET programming is doing. It's just that it gives us an easier drag and drop way to build things up, assign values, and later on use those values. In this lecture, I'd like to provide you with an intro to object-oriented programming. And this is going to start to tie in some of the things that we talked about in the previous lectures. The goal of the next few lectures is to simply provide you with a rudimentary mental model about object-oriented programming. I'm doing this to help you navigate the .NET Framework documentation, which is a collection of programming concepts that we can take advantage of within our UiPath activities to get work done. If you've never done any programming, this will also help you understand why we use dots and parentheses when we are interacting with these VB.NET snippets. And finally, I'd like to help kickstart your imagination about how to solve complex data management issues. And what I mean by that is to start thinking in a more abstract way more frequently. And instead of treating things like a customer's age or a customer's address as different, disconnected things, we can start to think of a customer as an object that may have a bunch of related properties or things that it can do. What I'm not trying to do with this series of lectures is to teach you to be an object-oriented programming developer. That's totally out of scope. If you'd like me to create a course about becoming an object-oriented developer, definitely let me know and I'll consider it, but that's not the intention of this RPA Tech Primer course. Having established that, let's get into the meat of the topic. The 4 aspects of object-oriented programming that I want you to be aware of are classes, objects, properties, and methods. I'll give you a demo on each of these things in the next lecture, but for now I'd like to give you an overview so you can form a mental image. Then after you watch the demo to solidify the concepts, feel free to come back to this lecture to watch the explanations again, and then re-watch the demos, and it should all start to make perfect sense. A class is a programmatic term that can be accomplished in a variety of different languages. Ultimately, all we're talking about is using programming syntax to create something like a cookie cutter. It's basically a template that defines what an object will have inside it and what it can do. An object is the physical result of using a class, or a cookie cutter, to produce something. The object can hold data values, like name or age or height, and it can do things like breathe or speak or run or jump. Now, of course, I'm using an analogy of a human when I'm talking about the data values and things it can do, but you could also apply this same concept to something like a file, which of course has a size and a type, and you can do things with the file, like read it or save it or print it. Each physical result is what we call an instance. And if you're ever sitting in a room with developers, you might hear them talking about how we can instantiate an object from a class. That's just fancy programming speak for using a programmatic cookie cutter to produce digital cookies. Our class will define what kind of properties our object can hold. These will be things like data values, which are very similar to variables that we've discussed in previous videos, and these data values can be the same or different for each instance. If we stick with the human example, you could have 2 people named John and Phil, and each one of them could be 50 years old. On the contrary, Tom could be 32 years old. Each of them have an age property, and it's the same for some people and different for others. Where it gets interesting is when you realize that properties can also be other objects. And what I mean by that is a human object could have a heart object or a collection of two eyes or a mouth object or a hand object. And of course, the hand object could also have embedded objects inside of it, such as fingers, and the fingers could have objects like fingernails, and so on. Finally, methods are things that the object can do. A human object, for example, can breathe or run or jump. And methods are basically functions that exist inside an object. And of course, we talked about functions in previous lectures. So when we create a procedural program that starts on line 1 and works its way through the program, we talk about the program having things like variables and functions. Whereas when we take those same concepts and wrap them up inside an object, we instead call them properties and methods. So all of this is to help you get a better grasp on when do we use dots and when do we use parentheses, because it is something you'll have to be doing when you use certain UiPath activities. And again, I'll be doing some demonstrations of this in the next lecture. Basically though, dots are used to indicate that we're going to access a property inside of an object. So we first write the name of the object, then we type the dot, and after that dot, we type the name of the property we're interested in using. So for instance, here my object is John, and I want to get John's age, so I'm going to type john.age. And I can either set the age to a certain value doing this, or I can get the current value of the age by using this same approach. Another example would be if I had a car object, which is a Ferrari. If I'm interested in knowing something about the seat of that Ferrari, the Ferrari can have an interior, and of course that interior can have many different objects inside of it, like seats and steering wheels and carpet and such. But in this case, I'm interested in the seat. So I can say Ferrari object dot interior object dot seat object. The interior is an object, which is a property of the Ferrari object, and seat is also an object, which is a property of the interior object. So that example is a little more complicated than john.age, where age is just a number, but still a property of the John object. We also use dots to precede the name of any method that we call. And calling a method is referred to as invoking that method. So for instance, if I want my John object to speak, I would type john.speak. If I want to recline the seat of my Ferrari, I would tell my Ferrari object's interior seat to recline. And I use the dot to indicate that I'm calling that method of the seat object. And the next example is something we'll see frequently. Whenever we have objects that have properties that are numbers and we want to output them into some kind of a message that the user can see, we have to convert those numbers into what we call a string. So our number properties inside of objects will all have a method that we can call called toString. So of course I would type the dot at the end of my numeric property when I want to invoke the toString method. Now let's talk about when to use parentheses. Contrary to using a dot before calling a method, we use parentheses at the end of the method name when we're calling it. So if I want to tell my John object to run, I simply type that dot with the word run, just like I did above with speak. And of course, at the end of each method name, we use those parentheses. And the parentheses are there for a reason. They're there to potentially hold what we call arguments or parameters inside them. So in this third example, I've got a joint account object, and I'm using the dot to make a deposit. And then of course, inside those parentheses, you can see that I'm passing a value of how much of a deposit that I want to make. So that's why those parentheses are there. They are ready and waiting to hold parameters, which are essentially input values to that method, because the method can do different things depending upon which values you pass into it. Another scenario when we use parentheses is when we need to use an index, and that just means to reference a single item inside of a collection. And a collection is exactly what it sounds like. A bunch of similar objects all contained inside of an object that has a certain name. A good example of this is bank accounts. Any adult human being you know probably has several different bank accounts, whether it be checking, credit cards, and so on. So each human being you know, each human object, has a collection of accounts associated with them. And when you want to refer to one of their accounts, a computer could count through the list and it could say, I want to access the third account in your collection of accounts. The same thing can occur with addresses. You could have a work address, a home address, and so on. So if John does have several addresses associated with him, I could use the dot to access his addresses property, which is a collection of addresses, and I could use these parentheses to access the second address in his list of addresses. So if you're brand new to programming, I know that these terms like class, object, properties, methods, and all these dots and parentheses can be confusing. But in the next lecture, I'll do a demo so you can see it unfold before your eyes in a very simple way. So go and watch that demo video, then come back here and re-watch this one, and maybe even watch the demo video again, and I'm fairly certain that these concepts will start to make more sense to you. Okay, let's have a demo of object-oriented programming. Again, I'm not trying to make you an object-oriented developer here. I just want to show you some of the most rudimentary concepts so you can have an easier time forming a mental model, interacting with the .NET framework, and feeling more confident about knowing why we use dots and parentheses when we're interacting with the .NET framework. So I've got Visual Studio open. I'll go to File, New, Project, and as usual, I'll select Console App. I'll save it in C Development VS. I'll call it OOP-demo, and I'll click OK to proceed. So as usual, we've got our VB module, which we could rename if we wanted to. And I've got my main subroutine here, into which I can type console dot, and then double click on read line like we always do, and make a little space. Up at the top here, I'll type in console dot write line again, and put a message in here that says creating a new human object. Because what we're going to do is create a class that has properties and methods that is analogous to a human being. So as I said in the previous lecture, a class is simply a programmatic template that allows us to define the kinds of things that an object will have and can do. The syntax will vary depending upon which language you're using, but for VB.NET, I can type the word public, which means any part of the program will be able to access this. And then you can see that the IntelliSense is showing me a list of things that I can type, and the second item in the list is class. And you can see the IntelliSense says this declares the name of a class and introduces the definitions of the variables, properties, and methods that make up the class. So that sounds exactly like what I was talking about in my previous lecture. I'll type a space, and here's where I provide the name of my class. I'll say human being, and then hit return. Notice Visual Studio adds the words end class down at the bottom. So anything that occurs between public class human being and end class constitutes my template for my object. So inside this class template, I can define variables in a very similar way that we did in our program earlier. So I can say dim age as, and if I start typing int, we've seen this before. I can select int 16. I'll type dim first name as string, dim last name as string. So you can kind of see where I'm going with this. These are the properties of our object. These are the data values that the object possesses. Now I'm going to take a quick sidebar here and let you know that I'm actually lying to you a little bit. This is not the real way to create properties. The way you would create a property would be to type property iColor as string, something like that. But using properties the right way entails a little bit more detail than I want to get into right now. You'll notice that there's some little dots underneath each of these things, and when I hover over this, it's telling me that this is actually a field. And again, I don't want to go too deep into this right now, because I'd rather focus on the notion that these things are just data values that are part of the class, and I'm using the term property loosely. If you hover over this, it allows me to show potential fixes. And when I click on that, you see that there are a couple of options I could select here. instead of using dim like I am, I could use read only. Or in the second option here, instead of using dim, I could use something like private or public, which I'm going to do in a couple of minutes. When I first try to use this class, you'll see that I won't be able to access these fields, or what I'm calling properties, from within the program. So I'll change these to public in a minute. But for right now, ignore the fact that these are actually called fields and I'm referring to them as properties. Again, I'm not trying to make you an object-oriented programmer. I'm just trying to explain some abstract concepts, because the way that we'll actually use these things in the RPA tool will be about the same, regardless of whether we use fields or properties. So enough said there, let's carry on. Now, very similarly to how we defined a subroutine or a function inside of our program, we can do the same thing inside of our class. But instead of calling it a subroutine or a function, we're going to call it a method. But we still type it the same way we did when we were doing it in our application. So here again, I'll type public sub, and since this is a human being, I'll call this sub speak. And when I hit return, Visual Studio automatically adds those parentheses that I need, that, like I mentioned, can be receptors for what we want this thing to say. And then here inside the body of the method, I can do something. I'll type console.writeLine, and here you might recognize that I'm using a console object. I've typed dot and I'm invoking a method called writeLine, and now I'm going to use the parenthesis to specify a parameter, which is input data that I want writeLine to do. So I'll open my quotes and type I am speaking. And since our class is defining what this object can do, I'll just hit return a couple of times, triple click on this, and then paste it here, and our human can also walk. So here I'll just change this to I am walking, and now we have an example of how a class can define several properties and also several methods. These are data values that the object will have, and these are things that the object can do. So now I can go back up to my program here and start using this class to make objects. Using dim is the way we would define these if we were defining variables in a program. But since we're defining them inside of a class, instead of using dim, we need to use public. And this could be either public or private. And that's a little deeper than I want to get in this lecture, but that just controls whether these properties or methods are able to be seen by the program using the class. So now that we've created this class, which is our cookie cutter that defines the data values and methods that our object can do, let's go up and use it in the program itself. It's actually fairly simple to instantiate a new object from a class. It's going to look like a variable up here in our program. So we're going to say dim Henry, which is somebody's name, as new, and when I start typing HUM, you can see the list shows us human being. So I'm saying dim Henry, which is my object, as a new human being, which is my cookie cutter. And now that I have Henry, which is my object, I can type Henry dot, and now for dot, you can see that I can access my properties like age, first name, or last name, and I can even invoke the methods that I've defined, like speak and walk. So if I say Henry dot first name equals Henry, of course, and then I triple click and copy, paste, I can change this to last name equals Smith, triple click, Control C, Control V, and again I can use the dot there to access Henry's age property, and instead of a string, since age is an integer, I can type in something like 34. Notice I didn't put quotes around that. So what I've done on this first line is to dimension or dim my Henry object from my human being class or cookie cutter. And then I accessed the various properties and gave them values. And now I can use my Henry object to read its properties or even make it do the stuff that it's capable of doing. So I can use console tab dot write line. Again, opening up my parentheses to give WriteLine some input, and I can say our human's name is :space quote, and then to add on to that, I can use a plus sign, and I can type my object's name, which is Henry, hit tab, and again I can use the dot to display the various properties and methods that Henry has or can do. So of course here I want Henry's first name, so I type FI and hit tab, then plus, open my quotes and add a space to separate the first name from the last name, add another plus sign, and type Henry again, tab, and then use dot to access his various properties. Of course now I want last name, hit tab. So in this console.WriteLine statement, I'm simply adding a bunch of strings together. And two parts of that string is my object's first name property and my object's last name property. Now I can triple click that, Control C, Control V, and I can say our human's age is, and of course here I'll double click all this stuff, back up a little bit and type the dot again, and of course here I want to grab my age property. And now since age is a number, it would be best if I use the dot here to invoke various methods that age is capable of. And like I talked about before, there's this toString method that will convert a number to a string so we can add it together with the other string. So I'll double click on that, add my parentheses after it, and now we're going to add Henry's age property onto that string. So that's it. We've got a class down here, which is our cookie cutter. We've instantiated a new object, and we used its properties to provide values. Then we used those same properties to read the values back. So what we should see is creating a new human object, then we'll see the name and the age. Let's run it. And there you go. Our human's name is Henry Smith. Our human's age is 34. So now I'd like to drill home the point that this class really is a cookie cutter, and we can use it to produce multiple objects that can have the same or different data. So let's create another human being. And what I'll do is copy all of this information, Control C, and then hit a couple of returns just to sort of separate it here, paste that back in, and now you can see that it's complaining that Henry is already being used. So let's call this one Jacob. Now we're creating a new human being with a different name called Jacob. This guy will be Jacob Jones. His age will be 26. Now, of course, I need to take this reference, which is our object name, and paste that here. So we're going to set the right object's properties. Then we do the same thing here, so that we're going to read the right object's properties. So what we've done here is used this one class, like a cookie cutter, and we've created two different objects that have different values in their respective properties. So let's run it and see what happens. Now we've got a human named Henry Smith, who is 34, and a human named Jacob Jones, who is 26. Hopefully that's making sense. So here we've set and read the properties for both of these guys. Now let's invoke the methods. Let's make Henry, and I'll just hit tab here and use the dot to bring up these properties and methods. Let's make Henry speak. So I'll double click on speak and add my parentheses after that method. So notice I used a dot before the method and parentheses after the method. So now Henry is going to speak. And let's do the same thing with Jacob down here. We'll say Jacob dot, and I'll just type W to access his walk method and hit tab and add in my parentheses. So we're making our Henry object use the speak method, and our Jacob object is going to use the walk method. Let's run again and check it out. So Henry Smith is 34 and he's speaking. Jacob Jones is 26 and he's walking. Can Jacob also speak? Sure. Let's type Jacob tab dot sp for speak, add those parentheses, and run it. So now we have Henry Smith, who's 34 and he's speaking. We've got Jacob, who's 26, he's walking and speaking. So hopefully this really solidifies the term class and object and property and methods, because that's really what I wanted you to get out of this series of lectures. We can do all of these same things inside of our program, but object-oriented programming allows you to think abstractly in terms of entities like humans or files or customers and so on. And in that way, each entity can have properties and methods that are relevant to it. So if you need to, go back and watch that overview video and then come back and watch the demo again to really let this stuff sink in. And one thing that's really important to realize about these classes and objects is that we can take advantage of a bunch of pre-existing classes and objects in what we call the .NET framework to help us get work done. But if we want to get more advanced and create our own classes and objects to handle things like customers that have certain properties and capabilities, we can also write our own custom classes like this and then import them as activities that can be used within UiPath. I'll cover that in other lectures, but I just wanted you to have that information so you have clear context about why it's so important to understand this stuff.
Now that you've been exposed to some programming fundamentals, it's time for me to introduce you to the .NET framework. Before we talk specifically about the .NET framework, I'd like to provide you with some definitions and lay a foundation. There are two terms in programming that are somewhat related: frameworks and libraries. A library is essentially a collection of reusable classes. And by now, you know that classes are simply programmatic entities that have properties and methods. Creating libraries allows us to reuse code between different applications or projects. Ultimately, it makes application development faster. A framework is a little more comprehensive. It's actually a collection of libraries, and there's an additional layer of pre-imagined interactions between those different libraries. So in that sense, you're not just reusing code, but you're also reusing design ideas. But again, it really just boils down to making application development faster. Once you get more adept at programming, you can create your own custom libraries and frameworks that you can reuse. For more common things that aren't directly related to your business, you can also download third-party libraries and frameworks like Microsoft.NET or Bootstrap or jQuery and so on. Again, all of those options will make it faster and more reliable for you to develop applications. This all comes down to the DRY principle. Don't repeat yourself. When you do software development, the idea is to factor out common things and package them up in a way that's reusable so you don't have to keep writing the same software over and over again. To help you visualize this, let's first talk about programming without a framework. Let's say a company wanted to develop an application. Let's just call it Application A. Before frameworks came along, that company would write code that did things like creating files, writing information to files, saving files, deleting files, and so on. And in the process of creating that code, they had to create custom functions to calculate the difference between dates, format strings, add numbers, count words, and so on. All of that programming effort was done to support the application-specific features they needed to develop. And now let's say another company develops Application B. It used to be that for Application B, you would also develop code to create a file, write to a file, save a file, delete a file, and so on. And again, you might wind up creating those same supporting functions. And if these were created by a different company, you'd have different code that basically does the same thing. And of course, then they would create the application-specific features on top of all those supporting things. Engineers are pretty smart, so eventually they figured out that it would be beneficial to create a common repository of code that did common things. And that way multiple people could use it instead of having to rewrite those common things over and over again. So when we program with a framework, we first start by downloading and installing the framework, in this case, the Microsoft.NET framework. And that framework would have things like create file, write to file, save file, delete file, and so on. Then when you create a project for Application A or Application B, you simply reference that framework, and then the only thing you need to build for any application are your application-specific features. So clearly that saves a lot of time and makes programming much more consistent and reliable. There are many frameworks, but most RPA tools are going to be most focused on the .NET framework. This is a massive framework that was created by Microsoft way back in 2001. It's implemented in many different languages, such as C#, VB.NET,
C++, F#, and Xamarin. To understand how it works, we can simply Google .NET Framework documentation and examine various sections of that documentation. Once you have a fundamental understanding of it, and you're in the heat of battle creating an RPA robot, at that time you can Google more specific topics whenever you need help or ideas. Some examples of things that I would Google would be VB.NET concatenate string, VB.NET date difference, VB.NET create new exception, and so on. And that's going to show you the .NET code of how to do those things, and you can incorporate those snippets into your RPA tools activities. If you wanted to get examples for specific tools, you might Google something like UiPath split string or UiPath for each. And that way you'd see documentation that incorporates the .NET framework along with the UiPath activity that can make use of it. So let's jump into a browser and have a quick tour of that .NET framework documentation. This lecture is not intended to be a comprehensive guide about the .NET framework. I simply want to introduce you to it so you can use it as a reference in my other more advanced courses and when you're trying to solve problems of your own. So I'll type in .NET framework documentation and hit return. And there are a few sub options here, but I would usually click on this top link. And as we take a look at the page, you see that we've got get started stuff, we've got web related things, cloud, mobile, desktop, and so on. Under Getting Started, you've got these various sections here for different languages like C# or F#, and this is our section right here if we're using UiPath, because UiPath primarily supports VB.NET. Once you get past the Getting Started stuff, if you click on Web, for instance, there's a lot more detailed information specific to those topics. On the Getting Started tab, though, this basic language reference is a very important thing to look at. So when I click on that and scroll down the page a little bit, we've got some high-level sections like constants and enumerations, data types, which is going to be very important to look at. And I actually visited this page in one of our previous lectures about data types. As a refresher, you can see that this page goes through the various data types that are available to us and provides information about storage and what kind of values each of these data types can hold. When you click on any given link, it takes you further down the page and shows you remarks, tips, and even code samples of how to use them. So hitting the back button a couple of times, we're back to our top level list. You're definitely going to want to have a look at functions, because in this page, it talks about things like math and string functions and C-type. We use C-type to convert variables of certain data types into other data types. Math is exactly what it sounds like, and string gives us lots of powerful methods that allow us to interact with strings, such as formatting them, or specifically formatting them into currency or date times. You can search inside the string. You can trim things off the beginning and the end. You can replace characters inside the string with other characters, duplicate, reverse, and so on. And again, if you scroll down, you'll find code samples that help you understand how to use it. So hitting the back button 2 times. Modules is a good thing to look at, because this is going to have essentially classes like date and time, file system for dealing with files and folders, financial that can help you perform financial calculations so you don't have to write a bunch of code to do that, and then strings and math that we use a lot. Hitting the back button again, you'll definitely want to take a look at objects and operators and even statements as well. So again, this isn't intended to be a comprehensive guide to the .NET framework, but I did want to point you in the right direction so you can start exploring this, because I do make use of these things. So with that, I'll let you explore, and you'll definitely see me integrating a lot of these .NET classes and methods in my other RPA courses.